Today's Daily Dose of Math is a discussion about the height of a triangle. The height is also known as the altitude and is defined as a straight line drawn from a vertex of the triangle to the opposite side forming a right angle. The height becomes very important in many different levels of geometry, but even when we're dealing with the area of a triangle formula, area equals base times height over 2, we need to know the height. Let's look at this and use triangle ABC as an example. Triangle ABC is a standard right triangle with side lengths of 6, 8, and 10 units. In this case, the unit is meters. This triangle is very useful for examples in geometry, especially when introducing new topics. When I want to find the area of this triangle, I have different choices about how I can arrange the triangle and decide which side is my base. Usually I feel more comfortable if I use whatever side is flat on the bottom in the drawing as my base. I call that my base. In the top right example, side BC is my base. We know that it's 8 meters in length. We need to know the height so we can do the area formula. The height is a straight line drawn from vertex A to the opposite side forming a right angle. So in this case, side AC, which was already in the triangle and which we already know is 6 meters in length, is our height. That allows us to fill in our area formula. And we get an answer of 24 meters squared. If we rotate the triangle though, so that side AC is on the bottom, we can say side AC is our base. The height will be a straight line drawn from vertex B to side AC forming a right angle. Therefore, side BC, which was already in the triangle and which we know is 8 meters in length, is our height. Then we fill in our area formula. And of course we get the same answer. Now we rotate the triangle again so that side AB is on the bottom, and we call that our base. The problem here though is that the height drawn from vertex C to the opposite side forming a right angle has a length that we do not know. We know side AB, our base, is 10 meters in length, but we don't know how long this height is. What we can do, of course, is avoid arranging the triangle in this way. Avoid using side AB as our base, which means we use one of these other two approaches, and we know we can find our answer. In geometry, there are various different ways of finding the length of that height. But right now, I can do a little bit of a shortcut. Since I already know that the area of the triangle has to be 24 meters squared, I can plug that area and the 10 meter base into the formula and solve for the other side, the height. And I'm able to show that that height has to be 4.8 meters in length. The concept of the height of a triangle is simple, but is very important in geometry in all levels. That is today's Daily Dose of Math. Please like, subscribe, and share.